Hi, I am Cam Calderon and we are going to cover simple linear regression in R. Please note that I am going to focus in R or RStudio rather than in the inference of simple linear regression. So I hope this video is very useful. Okay, so let's start here. So this is RStudio. Remember that if you do not have this panel, you need to go to File, New File, RScript, and then you will get the same RScript where you can copy and paste the code from the book Principles of Econometrics by Colonescu. Okay, the first thing that we will do is to clear all objects in the environment to start fresh. This will allow us to um, uh, do not have interference of any other previous variable. The command is this one, and please use it with caution because if you use it well, you will delete everything in your environment. Yes, so you might lose work if you do not use it like rightly. Okay, the next thing is installing the necessary packages. So we will install DevTools, a package that help manage our packages. So I type install.packages in brackets DevTools. Remember that R works with packages. So everywhere or any time that we need to do something very particular or specific, we will need to use this function in install package DevTools. We do the same with the package remotes. We are going to use these two packages in order to open the book Principles of Econometrics by Colonescu. And well, I think I forgot to hit Control plus Enter in line 8. I will do that. It's asking me whether I have one or more of the packages to be updated are currently loaded. So I will say no because I don't want to install it again. I already installed the package DevTools in my computer, but if you haven't done that, I think you need to carry on. One way is to always say no to that statement, so it will download the package to you. Especially, that is one of the bugs when using a MacBook. So if you have that window, or if something appears in the console in this section that is at the bottom, you try to say no with the keyboard or click in no in the window that appears. I will do the same with the package remotes. I get exactly the same window, so I will say no, and it will start installing. Well, something is got installing there, I think. But the truth is that I had it already in my system, so I do not need anymore. The reason why I will put hash to these two commands, to these lines, because to be honest, I don't want to carry on hitting Control plus Enter running the code in the future because it's already in my computer. So I might reinstall the package in 2 years or so to get the updates if necessary. Okay, now I will hit a Control Enter in line 12. Yes, and I am downloading there a GitHub. Sorry, from GitHub I am downloading the book or the data from the book Principles of Econometrics by Colonescu. Sometimes you will need to put here comma force equal true. That happens sometimes. Sometimes it doesn't download it, so you need to force it sometimes. Is that this book is especially as well in some Mac versions of R. Do not know why it doesn't work, but anyway, sometimes it doesn't work because you already have installed it in your system. But I have found that some Mac in my sessions do not work very well like that. Anyway, we know that everything is fine because we got this sign at the bottom of the console, meaning that that sign is telling me that everything is okay. And then I go to load the Principles of Econometrics data, the package for accessing datasets, and that makes, by clicking on anywhere in line 14, I will jump directly to the next line of command, which is 15. So R will, if you are before on a comment, it will not read the comment, but it will carry on running the next line. So I think you can see here in my console that happened. And also look, after my function, I put the hash, so anything that is after the hash is not going to be read like as my code. So I can put as well comments to the right of my functions if that is nice for me to understand things. Okay, so everything perfect. So I got the correct sign here in the console saying that everything run very good. Now I will load and inspect the data set. I will choose this one, CPS underscore small. I use the function data. I think this function is coming from the library POE data. Since we already open the library, we will be able to have access to that data set. Once I control plus enter, once I run the line, then you will see that I have here in the console everything okay. Yes, so and here on the environment I get CPS underscore small 1000 observations of 9 variables. Possibly my picture is in there, but well, anyway, you will see that there is a link there, and you can double click it for you to see that you have actually a data set in there. Let's come back here to our RScript by clicking on this tab. Yes, let's plot a couple of variables of that data set. Look, we have here that we are going to look into the column educ. So that is why we use $, in line 21. So first the object, remember that this is this object, the data set, then the $, to establish what column we are going to look. Look, educ is a column. Let's check here. And you can see that the name educ is in here. Actually, we are calling the data of this column with that code in here. And we do the same for the column wage. Look, we have here another column called wage. Let's see where it is. Here. The first column, the first variable is wage. So we can call certain variables in this way with the $. Right. X lab is the label for the x-axis, and Y lab is the label for the y-axis. And X lab will read education and the y-axis wage. So let's sit anywhere on line 21 and hit Control plus Enter. Okay, and you can see here in the plot panel that we will see the same graph that you can find in that book by Colonescu. We can load another data set and inspect the first few rows. So if we click here data food, for instance, Control Enter, we will open another data set from the Colonescu book. And if we use the function head, this will display the first few rows of the food data set. So here you go, you can see and inspect the 6 first rows of that code in the console. And that is useful, especially when you need to inspect the data set to see if something is not working. Excellent. Now we are going to plot the food expenditure against income. So we are going to use the function plot as we did before. The function plot is very basic. There are many other packages that are better in plotting, but since this is like an introductory course and we are just plotting a simple linear regression, I think that is okay. And look what we are doing here. We are actually plotting income versus food expenditure. So x comma y, so in the x variable, the y comma, in the x variable we will have income, in the y axis we will have food expenditure. And here, look what is interesting. We are asking R to automatically determine what is the scale in the y-axis. This is y-lim, or the limits of y, and the limits of x. How? We are telling R that it needs to find the limits between 0 and the maximum of the variable food expenditure. Yes, and that is a very quick, just to establish. We will not need to do it manually, and that is great. xlab, I already explained, is the label for the x-axis, ylab is the label for the y-axis, and type P are these dots that you see in there. So let's hit Control Enter on line 28. If you see it anywhere else, it will not work, because as you can see, this line has been broken in parts. Especially I hit enter after the comma, so R will know I will carry on running all the code, because it has found an enter there, so it will work. So let's hit Control Enter, and you see that it jumped immediately from jump 28 up until the previous line. So it went directly to line 35. In the panel plot, on the panel area here for plotting, you will see that we have the observations for weekly food expenditure in dollars. Yes, that is the Y variable, and the weekly income in hundreds. So here we have in dollars in hundreds. So here we have the weekly income. Right, so now it is the time to perform a linear regression of food expenditure on income. So let's do it. So what we are going to do, remember, everything to the left of these two signs means that we have an object. So this object can be, the name of this object can be anything. I have chosen mode 1 because we are creating a model, the first model. Yes, mode 1 is model 1. You could have perfectly typed model if that is what you want, but mode 1 is okay as a name for an object. LM is the function for linear regression. And look, here, this is the Y variable. Food expenditure is going to be a function of income. Yes, so income will be the X variable. And here we type comma and then data equal food. This sign here means that we are running a regression. Yes, we are telling that food expenditure is a function of income. And this creates a linear model predicting food expenditure based on income. So let's hit Control Enter here. And you can see that it's okay. So we already got that data in there. I don't like actually that comment is around there. So I will go to the here, and I will pass that comment to the right. I will put it here at the top, because otherwise we will not be able to see what it says to the right. Okay, so we can carry on in line 38. In line 38, remember, everything to the left of these two signs is an object. So we are creating the object B1 because we want to save the coefficient for the beta 1. We extract the intercept constant term of the model, that is beta 1. And this is the function coef. Here I have the object mod 1 that I created in the previous line. It contains the linear regression, yes, of the two variables. And with 1, if I type this list 1, means that I am extracting the place where in the list in this object where I save the beta 1 coefficient, or the model saves the beta 1 coefficient. So if you run this, Control Enter, you will save in this object B1 the coefficient beta 0, which is or beta 1, which is the intercept of the model. The same for this beta 2. This beta 2 is actually the slope, the coefficient for income. So let's hit Control Enter. Everything is well here in the console. Look, I don't have any errors. Indicating if you get an error, usually is because possibly you have typed something wrong. And remember, you need to stop whenever you got the first error. You need to sort out that error to carry on, because this is a programming language, so you need to do the things in order and stop whenever you find an error. So now I am going to save in this object the summary of the model 1. This summary is the outcome that I can receive with the function summary, right? So if you type summary mod 1, for instance, you will get the outcome. Yes, I will show you in a minute. Yes, and then you will be able to get a summary of the model for detailed statistics. So let's do that. Control Enter. And then here, by simply naming as mode 1 and giving Control Enter, I'm asking R to show me what S mode 1 has. So let's go here anywhere to line 41 and hit Control plus Enter. Remember, it's Command plus Enter if you have a Mac. Yes, and then here you go. You can see here in the console that you have the results of linear regression. I will not stop very much in the interpretation, but you can see that the p-values are telling me that the intercept is significant at 6% and the income is less than 1%, so very significant income in this model. The multiple A square is 38%, 38.5%, meaning, and the adjusted A square, so meaning that the model is actually capturing a lot of the variability in the dependent variable by using that the income variable. So is actually okay. So the food expenditure is explained, the variation in food expenditure is very well explained by income. Well, 38% is good. Okay, so as you can see, we actually covered a linear regression. Now we are going to plot the data points. Here we have exactly the same plot that we did before. Yes, remember that we did this previously for food expenditure and income. So the main difference, I think, would be that we want to add a the regression line, and we do that with the function upline. Yes, so we use beta 1 and beta 2, the coefficients that we saved before here in line 38 and line 39, in order to create the regression line using the intercept and the slope. And here you go, you can see in the panel here that we have calculated the linear regression model, which is this line that is passing through all these observations. We can access the structure and details of the model and its summary by using the function names. So if I type names mode 1, this will display the available components in the mode 1 model that we saved before. So in that mode 1 object, you can see we have a list of coefficients, residuals, effects, rank, fitted values, assigned, QR, DF, residual, X levels, call terms, and model. The same for S mode 1, so I can, with the function names, I can get to know what names I have in certain objects. So if I click this, I will get call terms, residuals, coefficients, alias, sigma, df, R square, adjusted R square, F statistics, and the covariance on scale. So we have everything in there. We have as well that we can display the coefficients in different ways. So if you type mode 1 sine dollar coefficients, remember that we have that in mode 1. We just did that here. So if I look at the coefficients, the column coefficients, you will be able to see the intercept and the income, 83 versus 10.10. So this is beta 1 and this is beta 2. We saved them before as well. And we can also extract coefficients from the summary, which is S mode 1, the summary of the regression results that we previously saved in here. Can you remember with this S mode 1 object? So now with the S mode 1 sine dollar coefficients, we can access that column of coefficients in that data set in S mode 1, in that object. So here you go, you can see that 83.41 is the same intercept here, 10.20 is the coefficient, but apart from that we have the standard error, the t-values and the p-values as well here on this column, and that shows us what is the information that we have saved in that column in S mode 1. Okay guys, this is the end of this video. Next, I am going to create a example using the same code but using different data. I hope that that will help you for your projects, because sometimes when we do projects, we find some problems. So I hope that you will see how to sort out some issues when doing the same, or adapting the same code for your needs. Thank you very much, and happy coding. And I look forward to seeing you soon in another video of economics or econometrics. Oh, please do not forget to subscribe.